Today, we're going to talk about some of the scientific background of the themes of religion and science in the Dark Materials series by looking at the various different theories of the multiverse that might be involved in the different worlds of the Dark Materials universe and how they're related to spirituality or to the existence of God. So this poem by Percy Shelley, "Lift Not the Veil which those who live call life," suggests that if we peek behind the veil of appearances to what science reveals, that we might find something that disturbs the meaning of our life. The Dark Materials series aims at providing a view in which one could look scientifically at the world and still see some spiritual content which has some type of moral meaning. So the idea that somehow or other the creator of the world and the source of meaning and value of the universe was tied to the universe, tied to the astronomical structure of the universe, has a long history, as we talked about a little bit in our studies of Neoplatonism. So even in Schiller's Ode to Joy, which was set to music by Beethoven, the voice asks, "Can you sense the creator? Seek him above the starry canopy, above the stars. A kindly father, a heavenly father must dwell." So we had seen in our account of Neoplatonism that there was a great chain of being, and the very structure of reality reflected the moral structure of the universe, with God dwelling out beyond the stars and moving the stars in a circle, and all the planets rotating in divine admiration and love for the perfection that existed among the stars. And in Dante's view of the universe, um, the worst place on earth was hell. And as you moved up higher and higher towards the heavens, you got more and more perfect on the great chain of being. There's an underworld in the Dark Materials series, and in some way or other, the higher beings are located in the heavens and are more heavenly. So the great chain of being had the different hierarchies of minerals, plants, animals, human beings, angels, and then God. And in the Dark Materials series, you have the same type of hierarchy of creatures. And even within those levels, you have higher human beings and lower human beings. You have higher archangels and the lower angels. So the argument we're going to be considering is sometimes called the God of the gaps. The question was whether God is necessary to explain the universe. In St. Thomas Aquinas, an argument for the existence of God was given for how you need God to explain the universe. And as science explains more and more of the physical universe, the gaps, the explanatory gaps, or places where science can't explain things, become less and less. So the question is, when we peek behind the veil of the universe using science, will we discover any place left for God? And the postmodern view is going to be essentially a view that involved recognizing the limits of the human mind and its ability to understand and know the heavens. This poem by Edmund Halley, written at the time of Sir Isaac Newton during the modern period, um, illustrates the confidence of that modern period, that we can break into the mansions of the gods and steal their knowledge, just as Halley had used Isaac Newton's equations to predict the coming of Halley's comet. But by the time we get to the beginning of the postmodern period with Immanuel Kant, he's going to be saying that what characterizes human reason is that its nature asks questions that by its very nature it can't find itself capable of answering. So the postmodern view of reality was influenced profoundly by the different ways in which modern science hit up against various different types of limits of complexity in thermodynamics, limits of size and uncertainty in quantum mechanics, the limits of physical measurement in special relativity theory, and limits of the reach of physical law itself in our attempts to use mathematics as to peek behind the veil of even the Big Bang and ask where the universe came from. So in contemporary physics, there's an attempt to sort of transcend those limits. There are theories of the infinite universe in space. There are theories that attempt to trace back the origin of the universe before the Big Bang and explain how an inflationary universe gave rise to the known universe and to a multiverse. We attempt to go beyond the limits of size in string theory and in membrane theory that tries to hypothesize mathematical entities beyond the limits that are prescribed by quantum mechanics for what we can ever measure or come to know. And there are limits of mass and density that had to do with black holes and the unknowable nature of the reality within a black hole. So some of these are explored in the reading that we had for today from Brian Greene's book, The Hidden Reality, which is about the multiverse. So we're going to mention briefly 4 different kinds of multiverses. And we'll start talking about another 5th type of multiverse that might be involved in dark materials in the last class this week. The possibility of many worlds from the theory of quantum mechanics. But we're going to look at 4 cosmological multiverse theories, and the dark materials multiverse may involve some of those alternative universes that aren't just alternative versions of this reality. Later, when we talk about the other worlds interpretation of quantum mechanics, we'll see other worlds that represent different alternative realities arising from different choices and branching events from this world. So there's the infinite universe that considers the possibility that there might be parallel universes or parallel portions of the universe. The inflationary universe that has bubble multiverses that arose in the early origins of the universe. There's a string theory multiverse that talks about the membranes that gave rise to this universe and the possibility that there are other ones. And then there's the possibility that the universe is a simulation and that there might be multiple simulations. So the first one we're going to talk about comes from a series of articles by Ellis and Bundrick called Life in the Infinite Universe that considers the possibility that the universe is infinite. If the universe is infinite, then it might be the case that there are all kinds of regions. In fact, if it's infinite, there'd be an infinite number of regions that are physically separated from each other further than the speed of light can contact them. And if there's an infinite number of them, then the state of particles in each one of them will be varied randomly. And if that's the case, then if there's an infinite number of these, then eventually one will repeat, and one will repeat the set of structures and particles that exist in this universe. Just as there's only 512 different arrangements of X's and O's on a tic-tac-toe board. So if you play enough tic-tac-toe games, you're almost certain, in fact, you are certain, to end up playing exactly the same game as you played before. So if that's the case, then if the universe is infinite, then it's possible that there's another twin Earth somewhere, another world just like this one, that's exactly the same, that has you sitting here listening to this class and me sitting here giving it and saying exactly the same things because the particles are all in exactly the same configuration. Friedrich Nietzsche the postmodern existential philosopher, who we had talked about earlier as the source of the will to power theory, had recognized that the scientific view of reality, that saw reality as just the combinations of a bunch of qualitatively identical particles, allowed for the possibility of an exact repetition of this universe, or what he called an eternal recurrence. And he thought that the existential hero, if you lived your life from the inside completely and fully, that you would be willing to redo this world, to relive this life, it's for all eternity. Whereas to the most of us, that seems like an awful uh, judgment, to be stuck in the same reality and to have to repeat it again and again and again, to have to repeat this very moment again and again and again. Nietzsche thinks that if we were living life correctly, we'd be willing and enthusiastic, just like Sisyphus is happy pushing his rock up to the top of the hill. So, on that view, um, if we ask, why are you the way that you are? Well, of course, you're not the only one. If there's an infinite number of little pocket universes, um, and some of them are exactly the same as you, all the other different possible ways that you might be would exist in some of these other alternative universes. So, in this case, you are all the different possible ways that you could be if you ask, why am I the way I am? Um, and it's just a matter of chance and randomness that you happen to be identified now. Your consciousness happens to be identified with the you that exists in this alternative reality. A second type of multiverse, probably the most popular one, the one that's talked about most, is the type of multiverse that arose as a natural side effect of what's called the inflationary universe. This is some of the history of some of the discoveries that led to the idea that the universe arose in a big bang and had been expanding after that big bang. So were a number of different possible models of the universe that when Einstein formulated the general theory of relativity, um, he included a gravitational constant that would explain how quickly or slowly the universe would expand. So some universes might expand and then stop expanding and come back together into a so-called big crunch. There might be steady state universes that would continue to expand and then hit a steady state and remain the same size. And then there's a universe that continues to expand and accelerate in its expansion. And the evidence seems to be that that's the type of universe that we're in today. So the idea of dark energy and matter were ways in which mathematical physicists tried to account for the observed acceleration and expansion of galaxies and stars, assuming that there would be energy that we couldn't detect, that was pushing things apart, or matter that we couldn't detect. That was gravitationally pulling things together, decelerating the expansion. So, accelerating universe would be one in which the universe would continue to spread out. It would spread out even more quickly. In 2011, scientists received the Nobel Prize for their study of radiation from supernovas that seemed to indicate that we're in an accelerating universe, one that's accelerating or expanding even faster as it goes on. So in the inflationary universe, it's not just that the objects are moving away from each other in space, it's that the space itself is stretching or expanding, and the objects are sort of carried away from each other in it. In fact, the space is expanding much faster than any objects could actually move. So we have the Big Bang, and then the space in which objects existed actually expanded. So just as if we took a rubber band and stretched it out, the objects on it would get further apart or would get stretched out. So if you look at the actual PowerPoint for this, you'll see these little images. I don't think you can see it in the voice thread, but you'll see the images of the atoms being pulled apart by space expanding, as just as galaxies would be pushed apart by space expanding. The objects in space would be carried apart by the expansion of space itself. And the idea was that in the beginning unstable um, stages of the inflationary universe, that little bits of space might curl in on themselves and produce various different little bubble universes as it was expanding. Um, and that our universe, what we call the Big Bang, was the formation of one of these little bubble universes, and that there might be all kinds of other universes that have different starting conditions, and that are different little local places of the larger uh, universe from which the Big Bang arose. Um, Next time in the next class, we'll look at um, a theory called the Anthropic Principle that asks about the starting points of our universe and whether they're evidence that there must be a designer or some plan behind the universe to explain the possibility of intelligent life. But one form of the universe would be these different bubble universes, and it would seem that some of the alternative worlds in the dark materials series are, at least some of them, are alternative worlds of this type. They don't have alternative um, versions of this world, but seem to be different worlds altogether. And Lord Asriel discovers a way of moving back and forth between these worlds. A third source of multiverse theory in contemporary physics is what's called string theory. String theory is a new mathematical theory of what the basic constituents of the universe are, smaller even than protons and neutrons and electrons, smaller even than quarks or the other types of particles physicists have hypothesized about as the ultimate particles that make up the universe. And this has been part of the attempt to construct a unified theory, one that combines the physics of the very, very large and the physics of the very, very small. Einstein's theories of relativity explain the very large, and quantum mechanics, that we'll talk about later, explains the very, very small. So, string theory is an attempt to provide a more basic and more foundational account of the structure of the universe that would explain the origins of the different particles and their behavior that we see in other theories. And string theory also involves conceiving of universes as membranes within a larger bulk or a larger reality that um, somehow contains all of these alternative universes or membranes. So, just to give you an idea of how small strings are, you can watch this little video on the next slide that gives you a sense of scale. Strings are far, far much smaller than the even the smallest particles that we're capable of measuring. They go far beyond even the theoretical limits of any of what the uh, laws of quantum mechanics suggest are the smallest particles we might ever observe or interact with or measure. So if you were a proton, your electron would be the size of a pea. It would be about 13 miles away. But if you were a string, the proton would be the size of the entire known universe. So strings are much smaller than atoms are smaller than us. As you can see in this graphic. So the Planck length was the smallest length theoretically that it would ever be possible to observe or measure without affecting it or changing it. So string theory attempts to use mathematical hypotheses or mathematical constructions as a way of going beyond even the limits of that theoretical limits of quantum mechanics. So we had talked before about how Pythagoras had discovered certain harmonies as the basis for the physical world and as the basis for music and beauty. And it turns out that string theory is a theory that has a great deal of affinity with Pythagoras's theory of harmonics. You can watch the video in the slide that follows that shows how the different harmonics that gave rise to the different harmonies of the scale that Pythagoras discovered are the same harmonies of these oscillating strings that give an account in this mathematics of the four different fundamental particles that make everything according to string theory. So strings are tiny particles that are part of the larger surface called a membrane or a brane. And each of those branes are like a single universe, and that many of them may consist of different multiverses that exist in some larger structure that's called the bulk. So string theory allows for the possibility of different membrane universes that are separate from each other and might interact with each other only weakly. Um, so just as uh, Lord Asriel finds a way of moving between the different universes. So in string theory, you have these membrane universes, and it's possible for gravitational particles to somehow escape and affect other universes, whereas other forces are constrained within each of those universes. So membrane theory, as part of string theory, results in the possibility of different parallel membrane universes. A last type of multiverse theory that arises from contemporary physics comes from the idea that the world might be a simulation. And here, this idea is connected to discoveries that have to do with black holes. A black hole, remember, is a concentration of matter that's so heavy that the gravitational pull sucks everything into it, including light. So, since light can't escape it, it appears as a black hole. And Stephen Hawking, the famous physicist, had made discoveries about the entropy of black holes, which is the disorder or order or organization of the black hole. And he discovered that black holes, despite the fact that they absorb all the light, actually at the horizon of the black hole, called the event horizon, the edge of the sort of the point of no return, would be giving out a type of radiation that would be in the process of other things getting sucked into it. There would be a type of radiation that was emitted from it called Hawking radiation. And Hawking was able to see how the event horizon of a black hole contains information that tells us about its contents, that in fact is equivalent to its contents. So that the event horizon of the black hole is like a hologram of its internal contents, of its internal entropy. So this introduced the idea that the universe might be higher dimensional information that's stored in lower dimensional data or information. A holograph is 3D information that's stored in a 2D flat version. So the idea that the universe might just be a simulation, that is, a set of information and rules for manipulating that information, is the basis of all kinds of chemical simulations, So now, instead of actually running experiments, we can plug in the particles and models for how the particles operate and allow the simulation to carry out that experiment, as in this simulation of an ideal gas. So, on this view, there might be, if the universe is just a simulation of different information, then there might be other possible simulations that would have slightly different information. Julius Borges, the Argentinian writer, wrote a short story called The Library of Babel, in which all the possible books that might be written of a certain length were stored. It was an infinitely large library, or unimaginably large library, if not infinite. Um, and all of the different possible strings of characters of a certain length, of a book length, would have been stored there. So if the universe is a simulation, then there might be something like a library of Einstein, one in which all the different possible states of the universe were stored as different possible configurations of physical laws and particles. So if we ask, why is the world the way it is, or why is there something rather than nothing? That question would no longer have meaning, because all the different possible ways in which the universe might exist would exist as possible configurations within the library of Einstein. So if we ask what the relationship God might have to the most fundamental laws of nature, um, we can see that these theories, in some way, attempt to avoid or try to get away from the necessity of finding some source for the basic laws of physics, um, by assuming that there might be all the different possible universes, and suggesting that the reason why the universe is the way it is simply a matter of randomness or chance. Brian Greene tells the story of meeting the famous philosopher at Harvard, Robert Nozick, um, who suggested that even if he found out the laws that govern all the physical universe, he still wouldn't know the answer to why those laws and not some other ones. And Nozick suggests that there is no answer to that question. He quotes Wittgenstein saying that when we feel that even if all the possible scientific questions be answered, the problems of life has still not been touched at all. Of course, there is then no question left, and just this is the answer. The solution of the problem of life is seen in the vanishing of this problem. So if there's not an answer, that's not a problem. That just shows that there was never a problem in the first place. So um, Nozick and Green suggest the possibility of a multiverse, a set of possible universe that consists of all the different possible ways that the universe could be. So if we ask the question, why is there something rather than nothing? Well, there is a possible universe where there's nothing, and there's a possible universe where I don't exist, and there's a possible universe that exists where I'm all the different possible things that I might be. So the fact that I'm in this one is simply a matter of random chance. And there's no gap in which God or spirituality or any type of meaning or value would be necessary. So in the very origin of science, there's a Hippocratic treatise on science that said that science arose because they did not want to look upon the naked face of chance. So they turned themselves over to science, and as a result, they're released from their dependence on chance, but not from their dependence on science. So contemporary multiverse theories attempt to give ourselves over to the naked face of chance. And what's interesting about Philip Pullman's universe is that he attempts to give a scientific account of the universe, but one in which there's still room for a type of value or spiritual nature, in this case, the dust. There's a false one, which is the authority and its representatives in the magisterium. But the fundamental qualities of nature turn out to be something that has a type of spirituality, not in the very big or the small, not beyond the limits of the universe, but sort of behind everything that exists in dust. So, William James, the philosopher and psychologist of the beginning of the 20th century, had identified in one of his works two different types of people: the tender hearted, who aim at doing justice to the values of the world and want to make sure that um, they're equal to the beauty and the goodness of all the things that exist. They won't allow any veil to be drawn over their heart or allow their soul to wither. And they're happy to make a leap to believe in something that endows the universe with meaning rather than ignore the significance of some good. Whereas the tough minded is someone who doesn't want to be fooled, who pursue the truth no matter how painful, and wants to look reality in the face and not turn away. So Philip Pullman is a sort of a strange combination of these, because in his he's not turning to magic and fairyland the way that Tolkien is, thinking that there's an ideal reality beyond this reality that's somehow more real. He's the postmodern view, suggesting that if we look to um, the scientific understanding and factual understanding of the world, we'll see um, that there are no facts or realities beyond this one. Yet at the very same time, he wants to say that there might be features of this physical world. He's tender-hearted enough to think that there might be physical features of this world, not something beyond this world, but physical features of this world, some fundamental particle like dust, which is the source of consciousness and value, and that it might be some benevolent force guiding events for the good of the conscious creatures that arise from it. So, uh, the nature of dust is to believe in some reality outside of this world that's good without making it into an authority, without nailing it down within this world, without attempting to bring it into this world and say, I know what it is, and therefore everyone else has to believe in it and act in accordance with it. It wants to walk a fine line between nihilism and saying that there's nothing, and fascism or totalitarianism, which says there's a truth and you all have to obey it. And I can use that truth to as a cudgel or as a chain to force you to comply with it the way that the authority does. So, in some ways, there's a similarity between what faith and science does. Um, Faith believes in a moral value to the universe in hope and in faith, even when it can't see one, and continues to believe that acting, being a good person, even when you can't save everyone, is still a worthwhile thing to do. In the same way, the scientist continues to search for some hidden structure or law, even when they don't see it within the surface appearances. They continue to peek behind the veil in the hope that they'll find some order and structure, that they won't be given over merely to the naked face of chance. So, Simone Weil had done something that's in some way revealing of the moral structure of the universe of Philip Pullman. She said, when men do not believe that there's infinite mercy behind the curtain of the world, or when they think that this mercy is in front of the curtain, they become cruel. So those who don't believe in any God or any value at all, who are complete nihilists and believe that all is permitted, become cruel. Um, and those who think that the source of moral structure is in front of the veil, something we can see, and is the secular order and authority of the magisterium, they become cruel as well. So Philip Pullman's view of dust and the destiny of those people who return to dust after they're freed from the underworld, and the way in which love and the adolescent temptation that Lyra and Will give into alters the very structure of the destiny of dust. That attempts to have a belief in some moral, infinite mercy behind the curtain of the physical world, but one which still in some way can guide us and influence us, can serve as an ideal, without at the same time becoming something in front of the curtain which we can use as an authority or as a rule. You may want to think about the end of the Dark Materials trilogy in these terms, whether the new victorious revolution um, and the remaining remnants of Lord Asriel's forces and the angels, whether they're going to end up becoming another authority or whether they'll be capable of guiding the universe towards good in a way that isn't tyrannical. It may be consoling to you to know that there is also a universe in which you've already done all your work and you've completed it and you understand it perfectly and you're getting all A's. Of course, there's also a universe where you haven't started your work yet and you're failing all your classes. So you should take some consolation from the fact that you happen to be in this universe. This little demonstration just shows you the size of a string in comparison with everyday objects. This is an everyday object like the apple, and we're going to decrease in size by orders of magnitude or by powers of 10. So about 10 to the minus fifth, you get to the level of cells and DNA strands. At 10 to the 11th, we can see the size of an atom. And at 10 to the 13th and 15th, you can get to the size of a proton. If you were a proton, the electron would be about the size of a pea, and it would be about 13 miles away. So most of the inside of an atom is empty space. That's the size of quarks. And when we get down past 10 to the 19th, you get to the point where it's impossible for physicists to detect anything that small. And you can see that many, many, many orders of magnitude smaller are a string. If you were a string, the proton would be the size of the entire universe. So about 10 to the minus 31st and 10 to the minus 3rd, you finally get to the size of a string, which are the hypothetical mathematical constructs out of which the fundamental particles are thought to be made according to string theory. This is to illustrate the way in which the fundamental resonances of strings in string theory and the different fundamental particles corresponds to the basic harmonics of a vibrating string that Pythagoras had first discovered. String theory as a theory of the universe is the last in a long series of mathematical attempts to construct the nature of reality out of numbers the way that Pythagoras did. So when you look at a string, you can talk about the different harmonics. The second harmonic has 2 oscillations of the string. The third, the fourth, and those correspond to the different tones of music that corresponded to the integers that Pythagoras discovered when he discovered the basis of Neoplatonism, that there was a hidden order in the universe and that our minds responded to it by a feeling of beauty. And the mathematics of string theory has the different fundamental particles corresponding to the mathematics of those different harmonics. The string wiggles or oscillates at different frequencies, and the different particles correspond to the different harmonics in the string. So string theory is in some ways updating as a fundamental theory of the universe that discovery of the Pythagoreans, that the world is created out of number.